All right, everyone, welcome to this video. Our objective today is that students will be able to graph linear functions by converting them to slope-intercept form. Uh, Previously, we have graphed equations, but this time they may be in a way, we might be given the equations in a way that isn't intuitive on how we graph them, and so we have to rearrange the equation so that it makes sense. First, I want to practice that skill of rearranging an equation. So to do so, you're going to need to be able to solve for y. Get y by itself in a scenario where there are more than one variable. So we've gotten pretty good at solving for y or x or b or c or whatever the variable is when that's the only variable. But what about when there's two variables? I have an x and a y. Well, that just means I'm not going to get a final answer that's a number. We're just going to get y by itself. So the goal here, just like when I solve for any variable, is to isolate that variable, get it by itself. And so that's my goal. So my first step is to get rid of any addition or subtraction. I have a positive 3x here. To get rid of a positive 3x, I do a negative 3x. Subtract 3x from each side. These will cancel out. And so on this side, I only have 2y equals. Over here, I have 8 minus 3x. I can't subtract 3x from 8. They're not like terms. So I can just rewrite this as 8 minus 3x. Right? They're not like terms. Can't do anything. All right? So now I've gotten it to this. I still have y is not by itself. I still have this 2 with it. The same 2 times y equals 8 minus 3x. Well, to get y by itself, to undo the multiplication, I divide by 2. Whatever I do to one side of the equation, I do to the other. And with division, I have to divide to every single term. So these cancel. On this side, I'm just left with y. 8 divided by 2 is 4. And negative 3 over 2x. I can't, 2 doesn't go evenly into 3, so I can leave that as a fraction. It's 3 over 2x. And so now I have y by itself, and I have solved for y. I'm not getting a final number because when I have two variables, they're unknowns, and we can't figure them out with just one equation. So we have 8 equals 4 minus 3 over 2x. That's our final answer here. All right, let's go to you do 1. I want you to go ahead and pause the video and attempt to solve for y. Okay, hopefully you're unpausing here. This is, which means you tried it. Always try before you watch, because if you just watch and write down what I say, you won't learn anything, and the whole point here is to learn. All right, so we're trying to solve for y. My first step here is going to be to get rid of this minus 4x, so I'm going to add 4x to both sides of the equation. These cancel. On this side, I'm just left with 4y. And on this side, I have equals 20 plus 4x. 20. And 4x are not like terms, so I can just simply write 20 plus 4x. So now it's getting closer. I still have this 4y. The y is not by itself. It's still multiplying by 4. To get rid of multiplication, I do some division. Divide by 4. Divide by 4. Divide by 4. These cancel. You get y equals 20 divided by 4 is 5. 4x divided by 4. Well, 4 divided by 4 is just 1. So I could rewrite this as, I could write 4 over 4x, but that's not as simple as it can be. 4 divided by 4 is, sorry, I got my eraser. 4 divided by 4 here is 1, so I could really write this as 1x, or really I don't need a 1x in front of the x since this is just an x here. I really could just write this as, whoops. Is there an undo button? All right, not an undo button. So I was just going to change the 1 to a regular x. All right, so all right, here we go. Moving forward. Example 2. Now here's where we're actually getting to today's objective. I'm giving you an equation, and I want you to graph it. Every equation can be graphed. It's easiest, though, to graph equations when we have them in y equals mx plus b, because then we can figure out the slope, which is m, and we can figure out the y-intercept, which is b. All right, so that's our goal, to solve for y so that our equation is in this format. All right, so let's give it a try here. I have 5x minus 2y equals 12. Well, I want to get rid of this positive 5x so I can start to get the y by itself. To do so, I'm going to subtract 5x from both sides. Subtract 5x from here and here. These cancel out, so on this side I'm just left with a negative 2y equals. Well, I can't I can't do 12 minus 5x, right? Because they're not like terms. I can write this as 12 minus 5x. I just want to rewrite y equals mx plus b right here. And so now my next step, I'm going to divide each side by negative 2. These cancel. Get y equals 12 divided by negative 2 is negative 6. Negative 5 divided by negative 2 is going to be positive 5 over 2x. All right, because I can't, 2 doesn't go into 5 evenly, so I just leave it as a fraction. Now this looks really close to y equals mx plus b, but it might not look 100% familiar because y is by itself, it's good. But I have the constant here, negative 6, first. I keep forgetting I don't have a back button. Why don't they have a back button? They really should have a back button on this. Sorry, that's throwing me off. All right, so I shouldn't have boxed that in there. But so y equals negative 6 plus 5 over 2x. It doesn't matter. The order of operations does not matter at all, right? Doesn't matter. Let's look at something over here for a second. 3 plus 2. Well, it doesn't matter if I have 3 plus 2 or 2 plus 3. Both of those are 5. Both of those are 5. So, the order when we're doing addition does not matter. So I could really rearrange this equation so that it's y equals 5 over 2x and a minus 6. I just switched the order. I still have a positive 5 over 2x and a negative 6, but I switched the order. But now it looks like something I can graph, right? So I could come over, whoops. Oh my goodness. I'm not going to re-record this video, but let me go through the problem again, all right? Just to help everyone out, all right? So I'll do it quickly this time. We subtract 5x from each side. They really need an undo button. These cancel. I have negative 2y equals 12 minus 5x. I can't combine those like terms. Divide each side by negative 2. Get y equals negative 6 minus or plus 5 over 2x. Because these are two negatives, they cancel to a positive. All right, so I could rewrite this as y equals 5 over 2x minus 6, right? I didn't change anything. I still have a minus 6. I still have a positive 5 over 2x. I just rearranged the terms. And now this looks like something I can graph, that I know how to graph. So I'm going to start at my y-intercept, right? This is y equals mx plus b. Y equals mx plus b. I'm going to start at my minus 6. Put my first point here at minus 6. And then the slope, which is rise over run. So it's 5 over 2. That's my rise over run. So I'm going to go up 5. 1, 2, 3, 4, 5 over 2. Put my second point there. Connect them. Now I have a line. All right. So this line is equal to this equation right here. This equation right here. 5x minus 2y equals 12 can be changed into, where did y equals negative 6 plus 5 over 2x. So let me get this here. All right. I think that might have been a little confusing. So let's try the next one. All right. Let's have you try the you do. It's not my best video. Let's have you try the you do. All right, so go ahead and pause and try this. Okay, hopefully you're unpausing and you're ready for me to go over it. You may not have gotten it from the first one. Honestly, I was a little confused on why the back button wasn't working. So we're going to start by adding 2x to each side to get rid of a minus 2x. We're trying to get y by itself first. Remember, we're trying to get it so it looks like this. Y equals mx plus b. So I add 2x to each side. I end up getting these cancel. I left with 4y on this side equals 4 plus 2x. So I could write that as 4 plus 2x because I can't combine those. They're not like terms. And so then I'm going to divide each side by 4. These cancel. Get y equals 4 divided by 4 is 1. And 2 over 4 plus 2 over 4x. 2 over 4 simplifies to 1/2 x. All right. So now I have y equals 1 plus 1/2 x. Y equals 1 plus 1/2 x. I could rewrite this. I could switch the terms, right? I could switch the order of this and the positive 1. So I could rewrite this as y equals positive 1/2 x plus 1. I still have a positive 1 and a positive 1/2 x. Just rearrange the order. Doesn't matter with addition. So now this looks like exactly like my equation here, y equals mx plus b. So the b tells me where to start. I'm going to start at 1 on the y-intercept. And I have 1/2 x. I'm going to go up 1 over 2. I only need 2 points for a line, but I could do this forever. Up 1 over 2, up 1 over 2. Can even do it back in reverse, down 1 behind 2. Doesn't matter, can even do it reverse. You can see that as I'm plotting my points, it's connecting into a pretty straight line. All right, so I can connect these now. And now I've graphed the equation. Here's the original equation. Here's the graph that matches it. All right. All right, let's try one more. This time, let's do a little distribution first. I'm going to start by multiplying 2 times 3x. Get 6x minus 4y equals 12. So now I'm going to have to solve. I'm trying to get this y by itself here. So I've got to get this y here. I'm going to start by getting rid of this positive 6x. To do that, I do a minus 6x to both sides. These cancel. I get negative 4y equals 12 minus 6x. And now I can divide each side by negative 4. These cancel. I'm left with, I'm going to finish my equation up here. Y equals 12 divided by negative 4 is negative 3. And negative 6 divided by negative 4 is going to be a positive 3 over 2. You got to get it good at simplifying fractions. So now I have y equals negative 3 plus 3 over 2x. Again, if I want to just change this so that it's in slope-intercept form, y equals mx plus b, all I have to do is rearrange it. So I can say this is y equals, I still have a positive 3 over 2x, and a minus 3. So now it's in slope-intercept form. Now I know how to graph this. I start at minus 3, use pink to graph, down to 1, 2, 3, and I go up. This tells me what to do. Rise over run. Go up 3. 1, 2, 3 over 2. Up 1, 2, 3 over 2. Up 1, 2, 3 over 2. All right, this goes on forever and ever. I can connect these into a line, and I'm done. You only have to do 2 points, but sometimes I like to do more. Helps me connect into a straighter line. All right. Final you do. I want you to try this on your own, and then we'll go over it. So go ahead and pause. Okay, you're unpausing because you just finished doing the you do on your own. If you did not do it on your own, please do so. And let's dive into it. I'll go over it kind of quick and see you do. Start by distributing. I get this side just drops down. Negative 10 equals negative 5y. Negative 5y times negative 2x is positive 10x. All right, so now I need to get this y by itself here. I'm going to start by subtracting 10x from both sides. These cancel, so on this side I'm just left with 5y. On this side, however, I can't do a negative 10 minus 10x, so I'm just going to write negative 10 minus 10x because those are not like terms. And then I just have to get this y by itself, so I divide each side by 5. And these cancel. And I'm getting y equals negative 10 divided by 5 is negative 2. Negative 10x divided by 5 is negative 2x. So I get y equals negative 2 minus 2x. But again, I can rearrange these terms. I have a minus 2 and a minus 2x. So I could rewrite this as y equals minus 2x minus 2. I still have a minus 2x and a minus 2. I haven't changed the equation. I've just changed the order that it's showing. So now this looks like something I can graph because it looks like y equals mx plus b, where it's in slope-intercept form, where I have the slope as m and b is the y-intercept. So I know the b is the y-intercept, so this must be a minus 2. That's where I begin. And I know that negative 2 as a fraction is negative 2 over 1, so this tells me to go. My rise is negative 2, which really means go down. 1, 2. My run is 1. Down 2 over 1. Down 2 over 1. This pattern goes on forever. So to show that, I can simply connect them into a straight line. All right. This is maybe a little bit of a harder lesson than I was anticipating as I'm teaching it. If you need any help on it, you know where to find me. Thanks, and good luck with the rest of the math.